Hello, in this video I'm going to present you the second part of downloading IMERG dataset, precipitation dataset. In the previous video, as you may see on this screen, we were able to download the IMERG dataset, but it was only a text file that we received from the downloading process. This text file holds the link to the NetCDF raster datasets, and just up to in the first part it was not completely possible to download the NetCDF dataset. It was just we were able to only have the link to these datasets of our study area. So now we will proceed in this second part of the video, just using Python script to access the links that are available in this list in the text file, and download the actual NetCDF dataset. If you remember, these are the links that are for just each link represents a daily rainfall dataset in a NetCDF format, and you also see some PDF files which are important. It is important if you can read these PDF files as well. So when we try to download these NetCDF files, everything will be downloaded, including the PDF files. Then if it is important, you can have a look at the PDF files as well, so that you can get some important information about the dataset. So to download these NetCDF datasets, for which we have an access for the link at a daily basis, now we'll proceed to the Python script that we are going to use to actually download the NetCDF files. Then the final output that we are going to have after downloading these datasets will be a single file for every day. Then let me take you to this Python script. In this Python script, we have to make sure that we import the necessary libraries. Then the first step will be downloading the image data, which is our early dataset that we are going to do. And in the second part, because the output of this dataset is just a single file for a single day, then it means that we are going to have a very large list of NetCDF datasets. Then that could really be very difficult to manage when we try to proceed for further analysis. And then there will be a need to merge or bring together different NetCDF datasets into one file. Like, for example, for 1 year we can have one NetCDF file, but which holds daily rainfall dataset, and for another year also the same. So by that we can reduce the number of files that we'll be having in our computer. Then that will perhaps make the analysis that we would carry out further more simpler. So in the first part, downloading the image dataset, then we have to make sure that we import the necessary libraries. The first library is the OS, and the second library that we need to install is requests. Then OS provides tools for interacting with the file system, and the requests library is used to send HTTP requests. It is used here for downloading files from the URLs that are available in the text file. Then the next step is defining constants. Then we have to make sure that we have the authentication token. Otherwise, it will not be possible to download the dataset from the links. And also, we give where we want to save the dataset, and also URL file paths, that is a text file that we have seen in the previous video. So we have to give the directory or the location of this text file in our computer. Then for the first part, the authentication token, I have also shared the link for accessing the dataset. then we have to make sure that you are registered, and also from your profile registration you can generate authentication token. I may make a detailed video on this one if you need, but I can show you roughly as to how you can do that. Then this is the page for the portal, and then you need to, if you have a username, you can log in, otherwise you have to register. Then after registration, you have to make sure that you log in, and then by that you can have access to the authentication token. Then after, for example, if after registration you can log in, and then after login you will get to go to this page. If you go to your profile, then you click in the profile, and then you'll be able to see these options. We have these different tabs, and at the end we have the generate token. Then when you click this generate token tab, then you'll get this page, and in this page there are here options, show token, and you can, these are different tokens that I requested, that's why we have two. And then you can show the token here if you want, or if you don't want to show, you can also copy the token. If you mouse over here, it gives you an option to copy to clipboard, and then you can copy that token and paste it in the script as you may see it here. This is the authentication token that I copied. It is a very long authentication token, by the way. It is very long, so you can never try to remember this. It is a very long authentication token. Then you copy that authentication token and you paste it here, and then you give the directories where you want to save, and also the directory for the text file. Then that is the next step, is sanitizing file names. Then in here for example, you use the base name, and then here you sanitize the file name. Then the next step is just downloading data. For example, the headers, the header adds the authentication header with the token for secure access, and try except block also ensures the program handles errors, for example connection issues or whatsoever, and the save file writes the downloaded content to a file in binary mode. So this is the functions that we use for downloading the dataset. Then the main function is here, reads the list of URLs from the file, and then loops through each URL, because there are very series of URLs that are available in the text file. So this function makes sure that it reads all the files, and also loops through each URL, then sanitizes it into a file name, and downloads the corresponding file. So it gives the file names, and then also downloads the corresponding files that are attached to individual URLs. Then finally we execute the script, and this execution script, then this ensures the script runs the main function only when executed directly, not when imported as a module. So then after running these parts of the script, which is the first step for downloading the IMERG dataset from using the links that are already available in the text file, then we get all these files, the NetCDF files downloaded from the text file. As you may see here at the beginning, you see that you see that the PDF files are also downloaded. Then it also downloads the PDF files. Then in the directory where you save these NetCDF files, you will also find the PDF files. Let me show. Then this is the result of the downloading. Then it downloads a series of NetCDF files for the study area. Here is where these files are stored. You see, these are the NetCDF files. There are nearly more than 545 NetCDF files available. And mind you, this is only for 2 years. That, if you remember, we downloaded only for 2 years, which are 1998 and 1999. Then if you proceed just downloading time series data from 1998 up to 2024, then you can imagine how many thousands of files of NetCDF files you will have in your computer. So that's it's important to take note of this one, because we are downloading a daily data set. Then every day has a single NetCDF file. That's why we have we may have thousands of individual files for an individual day. If we proceed downloading time series data for many years, then we scroll down and then we will see the PDF files also here. Then if you need, for example, if you open this one, the first one, then this gives information about the algorithms. You can read through, and also the other one is about the metadata. I think gives some information about, it is a README document. Then it gives some information about the nature of the data. So most probably it is the metadata of the data set. Then after downloading this, as we have been explaining, we have like hundreds of, more than 500 files, or thousands of, we may have thousands of files if we download for many years. So we have to merge, combine these NetCDF files into a single NetCDF file. For example, for 1 year we can have one file. For another year we can have another file. So for 1998 we have one file, NetCDF file, but which stores daily rainfall data, and also another single file for 1999 that stores daily rainfall data. It doesn't mean when we merge them together, it is just combining the files. It doesn't do anything in the actual data set. So nothing changes. What it does is it zips all the files of a year together, and it generates a single NetCDF file. So to do so, we need to use another script. Then that is a stacking script, stacking daily rainfall data files to a single NetCDF file for each year. Then each year we'll have a single file. Then what it does is just stacking. No any kind of processing takes place in the dataset, so the nature of the dataset will not change. Then for this we import like XArray. We use XArray and also the array and OS libraries. Then we define the path to the folder containing the NetCDF files, and we know where these NetCDF files are. We give the path, and also we determine where to save the outputs. And then I just temporarily I want the script to create a folder which is named year, and then save the stacked NetCDF files in this folder, in the same folder of the output, but it creates a new folder which is a year within the main folder. Then ensure the output folder exists. Then we ensure that it exists, and then get a list of all NetCDF files in the folder. Then with this script, we just make sure that we just get a list of all NetCDF files in the folder. Then extract the year from each file name and group the files by year, because as you may see, this is how the NetCDF files are available in the folder. Then we have to make sure that the script detects the years, like here, and then tries to, based on this information, the year and the days, then the date, year, month and day, and then it tries to stack all the files with similar year. For example, if it is 1999, all the files that have a year 1999 will come together, and all the files that have a year 1998 will be stacked together. That's what it does. Then we have a function to stack files and save as the new NetCDF files. Then we have a function that stacks all the files and then gives saves them as a new NetCDF file. This function, we can load the files for the year using XArray and concatenate along the time dimension, and also define the output file name, save the combined dataset to a new NetCDF file. These are what these sections, snippets of the script do. Then process each year, then it processes each year, and then finally saves the files as they are, like this: IMERG precipitation daily 1998, then daily 1999. So now we have, from these hundreds, more than 545 files, we now create only 2 files that hold all the data sets. Then we have ordered at the beginning that it has to create a year, a folder named year, in the same directory where the input data sets are available, and then in this folder we'll find 2 files. Let me take you back. Then this is it, and then within this main folder directory, it creates a folder, this folder year, and then if you go inside, we find 2 data sets, 2 files. Then these 2 files they are similar. The information that we have here and the information we have here are the same. The only difference is that these 2 files hold all the daily NetCDF files in one file, and this one also the same for 1998 and for 1999. Okay, then we can visualize the dataset. Finally, we can select one of these datasets and then daily datasets and see whether we have really the datasets that can spatially be visualized. Then we plot one of the NetCDF files. To plot the NetCDF files, we use this script. We have to import the XArray and matplotlib also for plotting. Then these are important libraries. Then we have the file paths. That is one of I took randomly. I took this one, this first one, I think, and then we plot this file, and I provide the type, just the directory for this one, also the file itself, an individual file. It is also possible to go through all the files and plot them, but it is for us, just for providing you an example that I took only a single file for plotting. Then this script plots this single NetCDF file and shows us like this. So this is the precipitation data, and this is the latitude, this is the longitude of the study area. Then you can see the amount of rainfall. This is the daily mean precipitation rate per millimeter, in millimeter per day. And then you can see how much millimeters and where it happens in the data set. Okay, that's all. And if you have any other demands, you can drop your comments in the comment section. If you need this script, then I can send you, but you need to drop your email, maybe your email in the comment section, then I can share it with you. Okay, thanks. That's all for today.